Hello, in this lecture we're going to talk about elasticity of demand as it relates to revenue and the revenue equation. In prior lectures we have talked about what elasticity is in terms of a relationship between the price and the quantity, meaning if there's a change in price, what will then be the change in quantity? We know it will go down in terms of a downward sloping demand curve, but the question is how much will it go down by? If it goes down by a lot, then it was elastic. If it goes down by a little, then it was inelastic. This is an example of an inelastic demand curve in that it is more of a vertical demand curve, and the product example being prescription drugs. Say we have to take one per day in order to stay alive. That would be an inelastic demand curve because a change in price would then have little impact in terms of how much we purchased if we had the ability to purchase, given the fact that we need the drug in that case. What then would be the impact on a revenue equation in terms of the elasticity? If we look at our revenue equation, it is revenue equals price times quantity. So whatever quantity we're selling times the price that we are selling them for, that's how much revenue we are then bringing in. If we go through a thought experiment then and we say, well, what would happen then if price goes up a lot? And if we're talking about an inelastic good, what then will happen to quantity? We know it will go down because we're talking about a downward sloping demand curve. Question is, how much will it go down by? If it's inelastic, then the quantity will only go down by a little relative to the change in price. What then will be the impact on revenue if revenue is calculated as price times quantity? That would mean that revenue would have to increase. So given this little thought experiment, we can see that if we're talking about an inelastic good, then the increase in price would actually increase revenue. So the practical model would be that, well, if it's an inelastic good, what will happen to revenue when we increase price? Then revenue would generally go up. If we wanted to think through that in terms of graphing, we could just graph this more of a vertical demand curve line, pick a point on it, say it's $5 at this point, and we're going to say that the quantity at $5 is 50. And then we say 5 times 50, that's going to be what revenue is. How to calculate that? The area of that rectangle being 5 times 50, 250. If we pick another point on price, and we say let's pick a higher price here, say $10, and then we graph this out and say that the change in quantity went from 50 down only to 45, and we then took the 10 times the 45, the price times quantity, we get revenue of 450. And we can see that the 450 revenue, as we increase the price, has gone up from the 250 that it was prior. Now, in order to go through this thought experiment, you could graph a fairly vertical line, draw these two price points out even without the numbers, and just see the relative relationship in terms of the area of the graphs and the area of this rectangle as opposed to this rectangle to see if an increase in price would result in an increase in revenue. Obviously, if we went the other way, you'd have the same type of relationship in reverse. If we went from $10 to $5 when we had an inelastic good, we would be going from the greater area, 450 revenue, to 250, and we'd be losing revenue if we decreased the price. Let's do the same thought experiment in terms of an elastic good, something like pizza, something that has a lot of substitutes for pizza. If the price were to change, what would happen then to our revenue equation if prices went up? If prices go up, then quantity is going to go down, in this case, by a lot. So we know that quantity is going to go down if price goes up, but this time it went down a lot relative to the price. Then if price goes up a relatively little compared to quantity going down relatively a lot, what's going to happen to revenue? It's actually going to decrease because that small increase in price resulted in a large decrease in quantity. So if we graph this out, we can see this graphically again. If you just remember that the elastic demand curve is going to be more flat, more horizontal, and we pick a point, say $5, and we say that that's going to be at 200 quantity. 5 times 200 gives us the area or the revenue of 1,000. If we pick another point, we say $10, we see this big change in terms of quantity from 200 down to 25. If we take the area now, we have the 10 times the 25, 250, and we see this big decrease from the 1,000 to 250, and indicating the fact that if we raise prices on an elastic good, we're generally going to lose revenue. Revenue is actually going to go down, and of course the opposite is true as well. If we were to go from $10 down to $5, we would be going from 250 to 1,000, and revenue would actually be increased by the decrease in price.